What were my impressions of the Twitter space? Kind of before Elon came on, nobody was really saying anything that I cared about. And after Elon came on, it derailed into other topics. So, like, it's fine. I'm destroying my sleep schedule. No, I went to bed at 4 a.m. yesterday. So if I do 3 a.m. today, that's an improvement. So I'm going to just try to debug one bug here. And then I thought we were supposed to hit an error. Bro. Hit R a few times. Oh. Okay. All right, yeah, we're just gonna do this. Chelsea Handler. Ho, 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 ho. Merry Christmas. Everybody, Merry Christmas. Except it's Hanukkah now, not Christmas. Don't you know it's Hanukkah, not Christmas? Okay. Fix warning in should ignore entity. Okay. So I wanted to do a little bit. I mentioned during today's Q&A that the compiler got so slow. It's taking like a second and a half to compile the game, which is too much, right? The line must be drawn here. So, this isn't going to be a too hardcore stream, but I just want to spend some time making some attempts to find dumb things. So, for example, infer types, the inclusive time is 1.8 seconds of the telemetry build. This is the profiling build, so it's slower than, the regular build by some substantial amount. So we spend 1.8 seconds inferring things. Of that time, resolve one ident is 150 milliseconds, which is not quite 10%, but 8%, something significant. So should that be as much? On the one hand, there's lots of identifiers. On the other hand, Are there 382,000? Probably not. We're probably yielding like a fuck ton. That's one thing I could profile, is how many times are we yielding although that might kind of solve itself later. Like pump run pipe is 70 milliseconds. Like, really? Why so slow? Like, all of these things can probably be optimized like a lot. So, yeah. Like, this is, okay, this is weird. Where was that? So we're also, I kind of don't like that. We're waiting around for the bytecode, but maybe we kind of have to wait for running bytecode. How much does that take? It's got to be substantial, right? Why don't I see it up here? Because it's 23 milliseconds right there. Or sorry, it's 12 there, 23 there. That's 35. It's 45, 59. It should be like very visible up here. Why don't I see it? What the fuck? Wait for running bytecode. 78 milliseconds. So not that much more than I pinged out, but like significant. Now, oh, was I looking in the right column? Oh, it's exclusive because the rest of the time is in semaphore, right? Okay. So usually I'm looking at exclusive because I want to know what the leaves are that are taking all the time, but this one is ending up in semaphore wait for, which is not great. Okay. 78 milliseconds. That's a lot, but it's not that surprising. One thing we could think about is like how to not necessarily do that. I don't remember under what condition we do bytecode like that. Anyway, so do polymorph is 200 milliseconds. That's a fucking long time. No, it's 353 inclusive. That's like a giant chunk of time. So investigating that is probably good. Because like, okay, so the bug that I fixed the other day removed a significant, like 100 milliseconds from polymorphing because we were polymorphing too much. This is still a lot. Like 12,000 polymorphs. Is that really how much we have, for example, in the program. I mean, it's a 200,000 line program. That's a polymorph every 20 lines, approximately. That seems like a lot, but then you also count yields and stuff. Yeah, I bailed off that call because it just didn't seem to be going anywhere that I cared about. I mean, the stuff Elon was saying was fine and indicates exactly, at least when I was on, it indicates exactly what you would expect, that the code base is massively overcomplicated and it's very hard to get it to do simple things. Like, of course, that's how all these web companies are. We know that. We know that. Okay. So there's several things that would be good to look at. One of them is find scope entry, or resolve one ident, which is 150 milliseconds. And the only reason, I mean, that's smaller than some of these other ones, but it's like, I feel like that could be substantially less, right? And then the other one is, like with ident resolving, right now, what we do is just the super dumbest thing in the universe. And I feel like there may be a way to there may be a way to do better. Like what we do is we literally walk up this linked list of scopes, right? And push and pop identifiers. And what we could do instead is, you know, depending, or like, you know, we start at the identifier at the leaf, and then we say, okay, we're looking for identifier X. Let's walk up the frickin' thing, right? So if we're like 8 scopes deep in a procedure, we linearly walk up the linked list of 8 scopes in order to get to the global scope, right? And you could imagine doing it a different way, right? You could imagine maybe for local scopes, you just have like some hash table of what are the identifiers that got introduced, you know, and then you, every time you enter a scope, you put all the members of that scope into the hash table. And then as long as you look up everything at least once, that's probably not more expensive. And then everything for all procedure local scopes, everything that you're looking for is right there. And so then you have a very fast query to know, like, is this in one of my local scopes, or do I now have to just bail out and look in the global scopes? Now, the annoying thing about that is it can't just be one hash table, because we do this out of order compilation. So it sort of has to be one hash table per active compilation unit, of which there are many. So it might eat some RAM to do it that way. But it also has the potential to just be tremendously faster depending on where we spend all our time. Now, that said, there is other stupid shit in the compiler. Like, for example, let me give you a for example. when you declare something as a common type, like S64, we actually frickin' look that up. We look up S64. And it's defined in the root scope. That's like even deeper up than any scope that you as a user can declare. So like that's the most common things are maybe the slowest things, right? So this is actually what we could do. We could make a telemetry zone. You know, even though this isn't the biggest impact, I want to look at it a little bit. I want to know some things about it. Is it a hash table lookup at each scope or a table? What it is, you know, I'm trying to save memory on not having hash tables all over the place. Although, to be honest, that may be stupid because our hash tables don't take that much. So we keep it in a flat array until the scope goes beyond a certain size, and then we convert it to a hash table. But the thing is, the load factors on our hash table is just like 70% or whatever, which, you know, if you're the array version is just like the arrays at user level. It's a dynamically expanding array. So like, that's like having a load factor of 50% on average, right? So maybe there's no point in that entire complication of doing those arrays. Maybe it should literally just be a hash table always. I'll show you guys the code for it because it sucks. It's like some of the oldest code in the compiler too. I wouldn't say it sucks. It's just very smooth brain, and it's been getting more complicated over time because we have all these exceptions about like what the fuck is going on in nonlinear compilation and stuff. So I would like to simplify it out as much as possible. It's very IQ 110 code. So like this is sort of what it is. Also, we have to be able to yield in the middle of the frickin' thing and continue later. Actually, and figuring out how to do that with the hash table. Actually, I kind of know how to do it with the hash table. It's just a little bit annoying. Okay, so like we start with the scope and then we just iterate up. And if we have to yield in the middle, we poke stuff in here so we can continue later. And we're like, okay, if we're in a struct, maybe we yield if that struct is not done loading, which I don't know why we don't just put an inserter here. Waiting on inserters is current. See, I wrote a good comment explaining this to my future self. Waiting on inserters is currently only manipulated from within one thread. If we would like to keep it that way. Oh. Yeah. Yeah. Yeah, this is a nuanced issue. Totally. Okay. Okay, if we're waiting on inserters in the current scope, we decide if it applies to us. Let's actually put I'm just gonna color that weirdly. So we ask that question. This is like some stuff that I do that is not as well-defined and robust as I would like about keeping things from deadlocking on each other. We still, in very common cases, get circular dependency errors, like if you have two usings in global scope and stuff. And so I need to redefine, there needs to be some redefinition of the semantics of what, when you say using blah in a top level scope, where does the identifier lookup start? Does it ignore other usings that are peers, etc.? Or do we just, you have to mark it up, but the error message notices that that's the problem and tells you to mark it up? We'll see. Okay, imperative scope, blah, blah, blah. Oh, that's for waiting on inserters. I could put a zone around that. I don't know. And then here's the thing I was talking about array or hash table. If block lookup is large, we use the hash, the hash table. It's on large lookup table, right? Otherwise, we iterate over the members. Now, the thing is, these two lists are kind of redundant. There's things we want to look at, like we used to have declarations with null identifiers. We might be able to remove that if statement. Yeah, this is much more code than I would like to run per scope. The inserter thing, I think we could do with the hash table model. It's just listening, like there was the one web guy on there who was like being annoying for a minute. Like just listening to people defend mediocrity is, it just makes me, I can't deal with it. I was like, you know what? I could spend my time programming instead. Yeah, let's do this. I'm going to set an assert here. Does this literally ever go off? And the reason this is there is I used to have dummy things that looked like declarations, but were other stuff. And they used to end up in this array, but I don't think that happens anymore. Oh, I guess it does. But that wouldn't go in the hash table. The question is, like, do we need... See, one of the other things I'm thinking is maybe we can get rid of this members array, which wouldn't... I mean, it would remove one if statement that might be somewhat poorly predicted. It wouldn't dramatically speed up this function, but every step you take to make the function simpler, it's like Twitter. Every step you take to make it simpler and delete cruft is good. So like, we're just going to fight for every inch here because this is a core part of the compiler, the identifier lookup. All right, let's just see what it's complaining about. I bet it'll happen here too. It's probably something really basic that I'm not remembering. All right, so entry is what? It's a declaration with a null identifier. It's a load directive. Oh, I don't think this is necessary anymore. Why is the enclosing scope the returns block of a function? What the fuck load directive is this? Dude, it took that like 3/4 of a second for that window to appear. Am I still... Oh, never mind. I was going to ask if I was still really big on the screen from this morning's stream, but I realize I'm not on the screen at all. Yeah, profiling wins tonight would be nice, but even... Really, I just want to spend time increasing my understanding. I'm chilling tonight, right? This is one of my days off, supposedly. I've only worked 5 or 6 hours today. Parse scope entry. Really? Parse comma separated declarations. Skip name. Oh, this is okay. I'm a dum-dum. This is a declaration that doesn't have an identifier, which is allowed to happen certainly in returns blocks and maybe in some other blocks. Now, why are we looking in the returns block? Okay, this is weird. We shouldn't ever be looking in the returns block of a function, except when from a return statement. This is preload line 391. Oh, you know what? This thing, right. That's what it is. So this thing is looking up itself. It's like, oh, is workspace defined in my scope? No, 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 etc. Okay, so that actually makes sense. So now here's the next important step. We're going to remove this. We're not going to worry about removing this right now. We are, however, going to add information. We are going to say, for example, in the returns block of procedures, the identifier can be null. However, we could work around this check by calling a version of this function that has null checking only if there might be some way to specialize this function. Not to worry about this, but it's hard because we might be in a scope arbitrarily nested inside the returns block, e.g. struct. literal nesting, etc. Okay. So now next time I go try to look at this, I understand at least one case when this can happen. So that is good. Okay, here's what I want to know. How much time do we spend in the hash table versus the linear array, like globally? And so yeah, we say TM zone, and we're going to say find scope entry helper large, all right, or find scope entry helper small. All right. And let's just see that. It takes so long to recompile this thing. Visual Studio. Visual Studio. All right. So, timeline. All right, so the part we're looking at is here. Find, look at all these hash table functions. Okay, find scope entry helper large. Has an inclusive time of 48 milliseconds. Small has an inclusive time of 127 milliseconds. Holy cow, you guys. Okay. Let's see if there's an easy tweak to that, because like I said, we switch over. Okay, so this is 128 plus 50 roughly, right? So 178 milliseconds. Can we turn the dial to reduce that total? So for example, this is called large lookup table. And when we bind things, why am I having, there we go, it's probably there. Convert to large lookup, okay. Let's actually profile this. Convert to large lookup. Max entries for small block. 12. What if we reduce that to 8? I don't know. We could also reduce the load factor on our scope table in a minute. So we're trying to beat 178, and this is, you know, kind of a noisy performance number. Who knows? So like small improvements don't necessarily mean much. I mean, big improvements don't even necessarily mean much. All right. Profile zone. Zone. Find large is 47 and small is 114. So that's 161. So like theoretically we saved 17 milliseconds. We're still spending all our fucking time in small, which is really surprising to me. Although not that surprising. It's sort of the issue is, You know, the real issue is we're calling it 1 million times, right? It's only 100 nanoseconds per time, which maybe is still too expensive. How much is a nanosecond? It's like a CPU is at 5 gigahertz, so it's 200 picoseconds per cycle. Like, how much is a cycle? How many cycles is this? Was this like 1,000 cycles? 500 cycles? Calzone. Calzone. Okay. Let's try to reduce 1 nanoseconds is a 1 gigahertz cycle, right? Okay. Yeah, so it's like 400, 500 cycles, which isn't that bad. We just would like it to be much faster, but you know, really, we would like to not call it 1 million times. And actually, it is pretty bad. Like, if you just look at what's here, I mean, it's a bunch of if statements, which, like this thing, this right here, we could put wait, we just returned entry at the bottom of this anyway. Wait, what's going on? What is this code? We have all these cases in which we return entry and then we return entry anyway. What? I hope that all got optimized out. Like, this code must have been doing something else. Okay, well, yeah, this used to be trying to do some stuff about the nonlinear compilation and blocking, and it got moved out. Okay, I suspect that won't make that much of a difference in the times, but we'll see. I mean, that run took a bit longer total, just randomness of the preconditions. So small before was exclusive of 112.54. $111.29. Yeah, it's, I mean, that's about the same. Let me just make sure I'm not missing something by deleting all this. But that makes me happy. what I kind of want to know is, you know, how many of these, how many smalls do we go to per identifier? So that's a thing we can profile, is how many identifiers do we look up total? And then how many times do we do large lookup versus how many iterations of small do we do? Actually, we know those numbers because telemetry tells us those. It doesn't tell us how many total identifiers, but we could actually put a counter there. So we could say well, actually, because there's all the yielding and stuff makes it a little hard. So total calls to find scope entry is 380,000. And then each of those calls we either yield out or we recurse up a bunch of scopes, which is why these numbers add up to much more than 380,000. Okay. I just made a release build just to make sure. So I'm going to run this on the tests. All right, well, that's already a win for tonight. We got rid of some crufty old code that did not need to be there. Probably the optimizer got it all. This is gross. This is something. The Lambda's parent block is still the static ifs block. Doesn't seem possible to correct this without doing a recursive scrub. Yeah, that's annoying. That's annoying. When the moon hits your pie like it hits your eye like a big pizza pie. That's annoying. That's annoying. Okay, apparently every instruction is individually heap allocated. Oh, of course. Oh, of course. What do you even expect, dude? These are C++ programmers. These are C++ programmers. Okay, I want to know a different thing now, which is okay. If something, otherwise we do the old thing. Okay, what is the something? We're going to do a zone, resolve one ident, stupid. Okay, and what is that? If no check-in is a dumb thing to look up, ident name. And this is going to probably slow down the compiler a bit, but that is why we're no checking it. All right. SA, I'm just being super dumb. I don't care. String void bool block where resolved scope entry was found. You got a problem with that? Oh, type code any. You got a problem with a variable name that actually tells you what you want to know about it? You're fired. String pointer procedure void struct array overload set any enum. This is fine, I think. Okay. Name. Oops, we wanted telemetry builds. Blukrizskip. Okay. Yeah, that's a much better name. It sounds like the backward talking guys from Twin Peaks. Dude, if you're going to come in my channel and your first chat is a yikes, you're not giving me a good impression of you. If you think that a totally reasonable programming thing is a yikes. All right. Let me see your code, buddy. Okay. What did I call it? Resolve one ident. Stupid. So I was just trying to get a counter here. Resolve one ident stupid is okay. It's less than 10% of identifiers. And way less than 10% of the thing. So we could fast path this, but it doesn't I was hoping it would be like way more. But it ain't. Like I said, though, they're probably significantly slower than the average one, but still not that, I mean, obviously not that much slower because it's 6 milliseconds. Six milliseconds. Okay. You don't know why making variable names short at the expense of understandability is the norm. Well, in the old days, when the Unix guys were programming, you probably couldn't have files that were that big because it took a long time to read the file. Because your hard drive was the size of a fucking washing machine, and it was a giant spinning magnetic disk, bigger than your house. So, like, decisions that are made back then do not make sense today. All right, I'm going to get some water, so I'll be silent for about a minute. And then, so resolve one ident stupid didn't, okay, actually, I want to take out this no check-in because etc. But I'm just going to say as part of an experiment, I measured here how much time was being spent. Although, wait, resolve one ident is 96 milliseconds. Okay, inclusive time. I was looking at the wrong column. Inclusive time is 54 milliseconds. So that's useful information. Looking up dumb identifiers like S64, void, etc. It was 54 milliseconds of the 500 milliseconds total. Because oh no, resolve one ident is above this. Of the 444 milliseconds total, so greater than 10%, which is worth thinking about eventually. But I am not jumping up to do it yet. Oh my God, since I was programming it past midnight, it's the 21st now. Okay. Right. All right, back in a sec. At the store, they had these albino strawberries. So I got some. Okay. Okay. Albino strawberries. Do they taste the same as red? They taste a little different. I wouldn't say better. They're just a little different. Okay. What do we want to think about now? So one thing we could do, like I said, is just always use the hash table. The thing is, I wonder how big is the median scope. Because I don't want to say average, on average, how big is a scope, because some scopes have like the scope for the Windows module has, 5,000 things in it. Oh. I measured the convert, didn't I? Convert to large lookup. Yeah, it really doesn't take that long. Because we do it when the tables are small. We do it on 1,000 different scopes, right? Let's just see for yucks. What happens if we change this to 1? I should put no check in here. Whoa. I mean, it ran in approximately the same amount of time. Like exactly. Which maybe proves that that complication is not worth it. Okay, so find scope entry helper small still has 1,000,000. Is that for empty scopes? Okay, hold on. So this is called max entries for a small block. Yeah, we literally should be changing every block, every scope, which is, kind of a waste here. So like literally, we should be able to assert false in here, right? Where are we? We should be able to assert false in here. Oh. I have a feeling that assert's going to go off. Oh, I just did something bad and my whole display is resetting 10 times. Hit some key combination. Okay. I bet this asserts. Yeah. Huh. Oh, this is the old breakpoint. We don't want this one anymore. Find scope entry helper. Five. Oh. Wait, we don't make the lookup table large if it's... There's some conditions around this. We only do it for data scopes. That seems like a mistake. Let's see what this does. So first we're just going to run it in debug again to see if that assertion goes off. It does. What is going on? Like we're literally converting to large lookup. Oh, we want this. Lol. Okay, this is confusing behavior, and therefore we should figure it out. Would I please unban you? I'll go review unban requests at some point this week. I usually just ignore them. You've never seen a profiler before, but you're saying yikes to my variable names. Good to know. Good to know. Okay. Okay, find scope entry helper still going off. So like, why? There might be some scopes where I put things in via a different method. It's line 275. Yeah, I'm thinking it's maybe the constants block, right? Yeah, it's the constants block. So we do bind things into constants blocks in a different way. Maybe we should. Let's just ignore this for a second. Because constants blocks are going to be, I think, a small percentage of our program. If the question was, what happens to our performance when we're all hash tables? This is like almost all hash tables. So there's no reason, I don't think we need to agonize on it anymore to answer that question. It's just if we want to convert to all hash tables, we need to do that. Okay. Takes about the same, actually a little bit less time. Who knows why? We might just do this today. All right. Convert to large lookup, we call 41,000 times, which we won't have to do. It's 11 milliseconds that we probably won't have to do at all if we just start as hash tables. Well, it's still a little bit because you have to allocate the freaking hash table. Okay. Find scope entry helper. Small. Nanoseconds. Large. 100 and... No. Wait. 30 milliseconds still? It must be happening for more than constants blocks. That's like too many. But we are down to 163 milliseconds, which is a little bit lower than we were. Although, again, that could be in the noise. Could be in the noise. Why is this still so many? Oh, that probably is empty blocks. That's probably how many fucking empty blocks we're cranking through. I kind of believe that. And that hash table solution would probably fix that. Just saying. Just saying. The other hash table solution, not the one about using hash tables for every scope, but the one about, you know, maintaining a hash table as we go up and down scopes. Although I wonder if we could do something a little bit more gooberish, like just say, like a scope could have a pointer to the first non-empty parent. I mean, that takes more memory. You know, but we might be able to save memory off scopes by some other means anyway and get it back. But then it's still more memory, because if we save the other memory, we would like to keep the other memory. Okay. Well, let me check YouTube for a second. You know, I uploaded today the YouTube video of the Q&A. It is up, so if anyone is curious, here is the thing. I will tweet it. Okay. Now, what do I do about this? So maybe these are empty scopes, or maybe there's some other type of scope that we're not accounting for. Probably both. So we could put an assertion there. Okay, I should have done that in debug build. I don't know. I just don't know. I guess asserts probably are enabled in telemetry build. I don't know. All right. I should have just run it because I knew that was going to go off, actually. All right, well, what else is going on? 2, arguments block. Yeah, I kind of believe that as well. Well, we got pretty far. That's a different thing. All right, so we compiled that whole thing. It's just on Sokoban game. Okay. Okay. So we could categorize all of these if we want. Looks like we're going to get through the Sokoban game. Yes. Okay, so here's what I'm going to do. Watch. Let them witness the power of this fully armed and operational bullshit station. Okay. What are we going to do? The following. We're going to go bam, bam. Like, I literally don't even care. Okay. So, the only reason we're doing this is to have different telemetry profile zones, which probably we could use counters or some other telemetry feature that I've never used and don't know how to use. So we're just going to do this because I know how to do this. Not even going to fix that space. I'm a full stack engineer. That's why it says FSE. Lol. Lol, 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 lol. All right, let's see the relative proportions. It seems like that one took a little longer, which might be instruction cache, or maybe it's just that we threw all those if statements in there and they're getting called a lot. So let's see that. Okay, full stack engineer. Okay, arguments. 14,000 visits to arguments blocks for 42 milliseconds. Constants, 23,000 visits. Members.count is equal to 0, 362,000 visits. Oh, wait, those are nanoseconds that I'm looking at. Wait, look at the right column. Inclusive time. Arguments blocks. Less than 1 millisecond. Constants blocks, 1 millisecond. Empty blocks, 13 milliseconds. That's non-trivial, but it's not a ton of time. Struct arguments, very small amount of time. So, what the fuck? Because these 4 cases comprise find scope entry small, which takes 100 milliseconds. What? What? Did I leave something out? Like, we literally have this, and it said this thing takes 100 milliseconds. This shit don't add up, guys. What? 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 Can someone explain to me what we're looking at? 100 milliseconds for small, which is a lot more than before. It was like, we had it down to something much smaller. Because this plus whatever this was, which was also smaller, was like 165. Maybe this number is just wrong now? No, that's probably not right. Is there something after the ifs? No, there isn't. What is going on? Okay, wait. These don't exactly add up, I don't think. Because this is... Wait, I'm not... So struct arguments is 8, right? Plus 362, 768, okay. Plus 23855, plus 14424. We have 40105. Oh, okay. Never mind, they add up. But the times don't add up. Like, what the fuck, dude? This is really a travesty that I don't know how to deal with. I'm going to have to eat some Japanese snacks to learn how to cope. Oh, sesame crackers. I do not have an explanation here. I don't know. I don't know if I can believe that 100 milliseconds number. If I cannot, it's going to make further work on this problem much more difficult. I could record my own timings just for this function, but I don't want to do that tonight. I feel lazy and maybe want to go to bed. max time times the number of calls. I don't know why this reverse hierarchy is giving me this. This looks totally wrong. Maybe that's part of the problem. Maybe the timings are just fucked. So find scope entry. This is weird too. Find scope entry helper is what we've been looking at. But find scope entry itself takes 190 milliseconds before going into the helper. Like, wait, what? What? Okay, that's just fucking nonsense. These timings are fucked, guys. I don't know what to do about this. This ain't taking 190 milliseconds. Wait, this doesn't have a telemetry marker in it. Wait, what? Okay. Okay, never mind. The 190 is this function. I don't know why I called it find scope entry. Okay. Sorry, I was confused. So that 190 milliseconds is all this stuff, which I believe. It's like a bunch of craptastic if statements. Okay, never mind. We're not bagging telemetry yet. Now, I actually don't understand why. So what is this can go past inserters? We don't set that anymore. So when we find an inserter, can we not just do this? I feel like that actually might be significant savings. Of course, it'll be mucked up by all the other things we did to make it slower just now, but oh, this is taking a long time. Is this infinite looping? Oh, because we need to set maybe it's this block belongs to static if thing. Oh. Right, never mind. We can't quite do this. We can't quite do this. because we allow you to proceed if you look up something in the same block as an inserter and you find it, which again is only really necessary based on oh yeah, you know what, this isn't as bad as I thought it was. Not as bad as I thought it was. Oh, yeah, it is, because... Wait, because it was this one. But I think we want this here. Wait, what? Bro, what is happening? Oh yeah, this is C++. Sorry, I was confused about what language I'm programming in. Still not good, really? Really? It's kind of ass. Let's close these out. Bro. Jeff. What's happening, Jeff? All right. Oh. Duh. Yeah, I kind of just want to toast all the ident lookup and redo it. But there's these complications. Okay, Jeff woke up, I guess. All right. So that's working. I don't know still what to make of these numbers that we got down here. Let's look at this one just to see if they're similarly confusing, which I expect them to be. So find scope entry helper, 400 milliseconds. That's a fucking chunky ass thing. And it's only 220 in the actual lookup. So half of the time spent in this function, fully half, is doing all these if statements. You know what? I'm thinking about a stupid ass hack just to see what it does. Because we were like, hey, there's 0 members here, 363,000 scopes or lookups. That's ident visiting scope. I wonder if we can skip a lot of those if statements if a scope is completely empty. Like, what if yeah, I mean, we kind of can't skip this part. But that's supposedly... do I believe that that's taking that much time? Let me see. Average for find scope entry helper exclusive is 400 nanoseconds. That's really a lot. That's more than it looks like. So I wonder if there is some case that's caused... Let me just see. So at the bottom here, yeah, we don't really do anything. Let's just check this. This inserter. Just making it easy to see. I wonder if that's taking all our frickin' time. It could be. Like, it doesn't look at first glance like it should take that much time, but sometimes it's sneaky. Find scope entry helper inserter. 10 milliseconds. So not great, but it's not 193 milliseconds. That said, oh, inclusive time 18 milliseconds. Bruh, I don't know. I don't know what to do about any of this. So it's not in this. It's not going to be this. These are new zones. So the claim is we're spending... Oh God, it could be this fucking mutex. Oh shit. I believe that. This is a story that I start to believe. .1 seconds. What? Oh. Why'd that take so long? Did we just hiccup real bad for no reason? 4.2. Okay. I'm going to just say that was a time when Microsoft decided to do things. We're going to throw that one out as being an outlier. All right. even though these are starting to take longer, just maybe because of the extra instrumentation. I don't know. All right. Find scope entry helper. Wait, what? Oh, I said module import, right? I thought it was mutex. What the fuck? That's even cheaper than the inserter case. I'm not that surprised because it just doesn't happen that often, necessarily. I mean, 100,000 times, actually. It does happen often. Oh, that's really a lot. So, guys, what is happening? We're claiming that we're taking this mutex 100,000 times, and that only takes 7 milliseconds, which, you know what? I believe, because computers are fast. That's 70 microseconds per mutex, right? Or what? Average, oh wait, nanoseconds. So that's pretty fast. That's taking and checking a mutex. But we're saying that somehow in whatever part of this function we're not talking about is, we're spending 193 milliseconds. Like, what? I mean, the average is just pretty long. What's a good GPU to get these days? 3DFX Voodoo 2. Is it in inserters? No, we just looked at that. Like, this is trivial. These are, we know what. I mean, maybe it's just all the cache misses from reading the parent block. Like, what the hell? Okay, that one, that took a little bit uncharacteristically long. Let's just see. Yeah. Okay, we're gonna toss that as a little more minor outlier than the other one. All right, so I'm starting to get tired. FSE cache misses. Oh, okay. We're starting to see some time. Dude, I have no idea. So we finally found where a little bit of the time is. Are we really saying the rest of it is running those if statements? Maybe that's cache misses on reading the nodes or whatever. Okay. But again, this is a mystery because I'm not sure how much to believe this because, again, we have this situation where this is 100 milliseconds inclusive. Right? But the full stack engineers that we added up are, oh, this is not one of them, are 12, 14 milliseconds. So again, maybe maybe it's taking the cache miss on reading current scope, except that to get here, we had to read the block flag. So that's already in cache probably, unless the scope is so big we don't have the other cache line. Scope is way too fucking big. That's for sure. Like, look how fucking goddamn big that is. Like, this is one thing we could do, is just figure all that out. I'm being very wasteful here. So the block flags are up here, but the members are, well, we don't know which cache line they're in because the root node also takes a bunch of bytes. We could figure it out, but look at all this crap. Crap holio. Yeah, maybe I go into block tomorrow sometime and just try deleting things. Because I'm sure that'll help. Because it seems like that's part of what's happening, is we're just taking cache misses on the blocks. I don't know that for sure. I'm not really about to try my patience by trying to run fucking VTune again, because I hate that program. It's like it was made by Twitter engineers circa 2020. So, yeah. But it feels that way. And so maybe it's time to finally slim this down. Also, I just wonder if I can come up with some more compact representation of how to store dudes in scopes. I don't know. I mean, there's two separate parts. There's all this data that really doesn't have anything to do with anything else. There's this owning statement thing here. There's this register for last statement value that, yeah. And waiting on inserters, that could be in a hash table. Like we would flag it as waiting on an inserter. Yeah, like we could just delete a lot of this memory. And since there are a lot of scopes, I don't even know how many scopes there are. It's a lot. Then scope traversal would be faster for sure. So maybe I should just do that before I do anything else. Now, the problem is, of course, we have a root node here too. It has a bunch of crap in it. Yeah, maybe I should try this again. Yeah. It may be time to like just try to hack this crap down. Are these belongs mutually exclusive? I think that they are, yes. So it could be one field plus a flag for which one is set. I think. That would be a thing that we could assert on. But like you could see how big this is already. It's like 8, 16 bits, 32, 64. Let's count in bytes. 8, 12. A gap. So that's 16. 24. And then this is another 16. That's 40. 48. 56. 64. 80. 88. 96. 104 bytes before you have a child node at all. All right. All right. It's a lot. And, and that would put the cache line break at 128. If I got that 104 right. So let's go back to asked block. So I said 104, right? And then we probably align here. Oh, but it's already 8 bytes. So 104, 5, 108, because there's padding. 116, 124. This is exactly... Wait, that can't be right. Anyway, this is around just before 128. Literally right here. So this is just probably on the next cache line. Unlucky. Unlucky. Would you need to move the current values into a wrapping struct? I don't know what you mean by a wrapping struct. Generally, there's a bunch of stuff here to think about. There's like, I mean, we should just make these nodes smaller. That is for sure. Even though removing these just helps with total memory, it doesn't help with this cache line thing, but we could, probably move some shit around or just reduce the size. Reducing the size of the base node. So this is the whole thing is I was going to do a little mini project. What the fuck? Motherfucker, do not do that. Okay. I was going to do a little mini project where we try to figure out how to store these more compactly, right? Because this could be an index into something on the Lexer, although there's more than one Lexer. But you could imagine at least all of these being a 4-byte index of just like the Lexer keeps a bunch of memory with these things and it just goes and spews them out, right? And that's pretty easy. Because we almost never need these. They're only for reporting errors. So like spending 24 bytes on the location info is banana cake. So it could be a 32-bit Lexer index within the Lexer, and then maybe an 8-bit Lexer index or something, right? So that goes from 40 bytes into, right, 5 bytes. That'll fit in among this other stuff, probably. That's pretty big, right? What did I say? Did I say 104 for this? So subtracting 35 bytes is like a third of the struct. Is it really that big? Wow. So that's huge. That's huge, actually. And then this thing, so this thing debug explain. Okay, here's what I want to do. I'm getting tired. I want to get rid of whatever no check-ins we have right now. Take the W on the small amount of improvement we got. And then we'll go back and oh. We could check this really fast. Okay. I think we convinced ourselves the problem is cache misses, but again, we don't exactly know. Okay, now maybe we find out if asserts go off in telemetry build. It's 3 in the morning. I said I wanted to go to bed at 3 in the morning. Did I hose it? What did I do? What did I do? Why cache miss is not visible within profile zones? Because that is not what kind of profiling tool this is. This measures the amount of time between 2 points. That is all that it does. Well, not 100% all, but mainly. Oh, I didn't. Okay. See, I deleted this thing here, and I just deleted the whole block, which is a bad idea if you want to succeed in the game industry. Bad idea. Let's remove this one. 420. Okay, what am I even looking for? Oh, I also just wanted to know if it asserts. I mean, I guess I wasn't looking at any specific timing this time. Yeah, 400 milliseconds, dude. It's a lot. A lot, a lot, a lot. A lot, a lot. A lot. Let's just run this. That's a small improvement because we're removing an if statement. If it's a highly predictable if statement, it's not necessarily that expensive, but you know what? Sometimes when you have so many if statements, your like branch predictor gets full and whatever. That's not a good scene. All right, so that looks successful. Oh no. Wait, I fucking changed something. Oh no, something I did messes with overloads and placeholders. I'm not even sure what. We might just revert it since we decided, but there was a little bit of code that I actually wanted to keep in here. That thing where we deleted the big block of stuff. Don't really see the problem, if I'm being honest. There's all this stuff. But we're just returning entry. There's no continues in here, right? There's no... It might be something I did in another file. What else did we do? Our branch predictor is still a thing. Yes. They are still a thing. What happens is the state gets cleared when you go into and come out of the kernel, I think. Okay, that's a Trivioso. We looked at this. Dude, I don't know why anything in there hoses us. So here's what I'm going to do. I'm going to copy it just in case. And we're just going to revert that file. Revert a Williams, my favorite tactic. The Williams maneuver, second only to the Picard maneuver. And then we'll just go see, does this test, for example, work? No, it doesn't. Oh, you know what I bet it fucking is? This fucking thing might be the problem. Like, it might be some kind of singularity. Yeah. Yep. Okay. So this is why we copied this file, because we didn't want to lose our work if we didn't have to. Bro. Broski. Oski doski. Oh no. Okay, that did change something. All right. I'm going to leave that till tomorrow when I'm fresh. Then. Anyway, we decided my best interest. We decided that I'm going to go do some memory saving maneuvers. And that'll actually be a little bit fun. It's a little bit annoying to have to do those things, but it's also a little bit fun. Like, especially just cutting down the root node, man. Cutting down the root node. Cutting down the root node. Yeah, it just would be a good idea to get rid of a lot of these things. Like, we actually use this? Could not find a polymorph source. I need to look at that. Yeah, it's kind of an issue. We walk up the polymorphs. This is a default value to one of the procedure arguments. We did copy it for polymorph. But at the time we didn't copy the body. I don't know that we do this anymore. Jackass. Do we do this anymore? Probably. I just want to know. Yep. Yep. Okay. Well, we don't necessarily have to do that anymore. Except that we do. Actually, we do. Anyway. However, we could set this, if we really need this, we could set this only on procedures, right? And that gets it off the base node, which is very helpful. This, I didn't write this, so I don't. The lambda pointer. Okay, this is something that I could just like frickin' look at. Okay, I feel like I should be able to get rid of this member as well. So my plan is, the biggest one is this astasticness. And in fact, I could start just with this, right? Because like I said, this is 8, 16, 32, 64. We've got a hole right here. So if I can turn this from 8 bytes into 4 bytes, it'll go into this hole, and we save 8 bytes immediately on every node. Which I think, do I output total number of nodes? No. Total bytecode instructions. There's a lot of nodes. Yep. Yep, and I see how I could do this. So these get copied off the tokens that come from the Lexer, and so I could do this in two stages where the tokens just have the 4-byte index. And then when we copy them off, we do this, right? Oh, you know what? It's not that straightforward because we do some things where we tweak these manually. But there are ways around that too. There are ways around that. I think I'll have to look at that. But anyway, just saving that 8 bytes for the load info is probably not hard. That can go to 4 bytes right away. Yeah, this could be made way slower. This is the project, I think, just getting this down. Getting it down. Memory saving stream. I don't know if I'll do it on stream. I'm having a chill Christmas vacation, and like I might just want to hang out and work on this for 1 hour at a cafe tomorrow and then just not work on it for a while. I don't know. I don't know. All right, thanks everybody. I'm going to bed. It's past my bedtime. Thanks for hanging out on the streams. And I'll see you later on.